I'm Saket, and now I'll be explaining about the hardware implementation of 128 Tap FIR filter. I'm using Quartus 2, QSys, and Eclipse Neos 2 for this project. I have opened Quartus 2. Click Project, New. I'll be selecting hardware, HFIR, next, Cyclone 2, and model sim for simulation, finish. Now I'll design a system in QSys. I'll give the same name as HFIR, and calling all the files here. Those are my project files: accumulator, flip-flop, hardware accelerator, multiplier files, and give hardware accelerator as a top level entity, and analyze these files. So no error, no warnings. Parameters, I leave this data width as 16 bits, and all are set. And here associated clock is set to as clock, and associated reset is set to as reset. Then finish. Yes. Okay, my component is designed. Now Neos 2. I have to create an interface between my component and the system. So economic version of Neos 2 on chip memory would be 20480 bytes. Then JTAG UART for communication purpose, and performance counter for checking the performance in the counting thing. Now I have called all the modules, and I will call my component into this. Yeah, modules and components are called in that. Now I will be connecting all the interconnections. I'm supplying clock for all the modules, reset for all the modules, and data and instruction for data would be given for all modules, and instruction would be only for the on-chip memory, because it has to fetch instructions from module. And I will be giving connections. I will change this to FIR. Yep. And no warnings. So because there are few errors. That's because I didn't assign the base address. Now I assigned the base address, and there are two more warnings. Those are because I didn't assign the reset vector and exception vector of Neos 2. Now reset vector for on chip and exception vector for on chip. Finish. 0 errors, 0 warnings. Save the system. Save the system as HFIR. Save, and generate the verilog files related to the FHIR, which HFIR, which I have just now did. So I have generated I'm generating all the verilog files, which I can compile it by calling. Now I'll include all the files here and compile that. To include all the files, I can just call the QIP file, which in turn calls all the verilog files here. I'll give the pin assignment just for only for clock, because the remaining pin all the remaining pins are inbuilt in the FPGA. Let's go to 3 volts. Save this, save and compile. Meanwhile, I'll open the NEOS to Eclipse for writing my C code and getting the output, and also my programmer when I can dump the code onto the board, the E1 board. This is the Eclipse. Compilation is taking some time. Compilation is done. Now I'll dump the code onto the board. Output files, SOP selected, start. Now my file is saved on the board, on the chip. I'll save this first, then close it and open the NEOS to Eclipse file, application builder. I'll call the SOPC file here, hardware, yep. I'll give a name, Tap FIR, and this hardware, smaller template, finish. Now this creates a workspace wherein I can build my project, run my project, and edit my C code to see the outputs. First I'll build the project. Project building is done. Now there's a C code, default C code here, which says as hello world, sorry, hello from NEOS 2. I'll run it using the NEOS 2 hardware. If the communication between the board and my software is built, then I get an output. Yeah, I got the output of hello from NEOS 2. Now I'll edit the C code. I have already written a C code, so I'll copy and paste it into this. Here's my C code, copy, paste into this. Here's the base address and the FIR performance address, and here I'm taking again the first case so that I can compare it with the software part. There's the code. I'm iterating the inputs and checking the performance thing. Okay, I'll save this and run it. Now I got the output here as -34 as the output, which is same as in the as in software, because I got the in software also I got same -34 as output, but the cycles are different because I'm comparing the performance between the hardware and software. So the hardware part was different and the software cycles are different. And this is the hardware part. Done with the hardware part. Now I'm closing the Eclipse thing, and the project is done. Thank you.